For this, you are going to need your science notebook, a glue stick, scissors, and then these pages right here. Going to need the density paper, the unit abbreviations, mass, volume, temperature, weight, and length, measuring matter, determining mass, and then determining volume. Okay, we're gonna put a whole bunch in here, but we will make more sense of it as we make our way through stations and labs. But we're just gonna get it all in your journal today. That way we can use our journals as we go through our stations. Okay. So the first thing we are going to put in is the density column here. We are going to cut this out. You can cut it out exactly, or you can do the square with the dots. So there's that. And then we have here a sponge, a bottle cap, and a screw. I'm going to cut these out real quick. Okay, and density, we will remember, is whether something sinks or floats. If it is less dense, then it's going to go to the top and it's going to float. And we know that if something is more dense, then it's go to the bottom and sinks. So what we're going to do is put our reminder in our journal. That way we can look back at this whenever we need it. Okay. Get all these cut out. This is a grape right here. So, in the journal, we are going to flip to our very next page. See that we have the solid, liquid, and gas. Then we have the changes in state where we talked about evaporation, condensation, freezing, and melting. And then this is going to be relative density. Let's see. Okay. I'm going to glue this down. Like this. Okay. Now I'm going to quickly color these. You have a lot to do today, so don't take too long coloring things. There's my grape, my bottle cap. I'm going to do red. Don't know why. Sponge green. A lot of people think it looks like cheese. However, it is a sponge. And then the screw is going to be gray. Okay. All right. Down here at the bottom, we have syrup. See that there's layers inside of our beaker. We know that this is syrup. I'm actually going to label it. In the middle, we have water. And then on the top, we are going to have oil. Remember, it's super important to remember that oil is less dense than water, so it means that it'll always float on top of water. It is also not soluble in water, so it does not dissolve. Okay, now what we're going to do is we are going to glue these objects in the density column. So a screw, if you'll remember from your observation stations, is going to go in the very bottom right there. Our grape is going to float on top of the syrup but sink in the water. We did a lab with that. And then our bottle cap, going to float on top of the water but be more dense than the oil. And then lastly, our sponge. It's going to be the least dense item in the density column and be on top of the oil. Okay. So again, I'm going to label these. All right, some keywords for density would be sink and float. We know that density is going to be observing like layers, and that the top is going to be less dense, and the bottom is going to be more dense, or the most dense. Okay. So the most dense item in here would be the screw, because it's at the very bottom. The least dense would be the sponge, because it's at the very top. If I were to ask you what is more dense than the oil but less dense than the water, it would be the bottle cap, because it sinks in the oil but it floats on top of the water. Okay. There we go. The next thing we're going to put in is going to be our measurement. This is going to go right here. Okay. Perfect. And while we're at it, we are going to put the metric abbreviations right next to it on the next page. Okay. Awesome. This is going to be measurement of matter. All right. So mass, we will measure with our tool. So with this, we're going to talk about the different physical properties that we measure. We have mass, volume, temperature, weight, and length. Mass, the tool that we use is going to be a triple beam balance. This is going to be metric units. Remember, in science and most of the other parts of the world, they're going to use metric units. That's going to be grams. However, customary units, or units that we would usually hear about in America, that would be pounds and ounces. Okay, I know that grams is going to be grams. Let's see. Pounds would be LBSs, and then ounces are going to be OZs. But remember, we want to always use our metric units, because in science we use metric. I'm going to go ahead and highlight these so we remember. Okay. The next thing we are going to measure is going to be volume. And for this, we are going to use our tool. It's going to be a graduated cylinder, or a beaker. Okay. The metric unit that we're going to use is going to be milliliters. And that's going to be ml. The customary units for this one is going to be fluid ounces. But again, we're always going to use the milliliters, okay? For temperature, hold on. Okay, and our next physical property that we measure would be temperature. That's going to be measuring the thermal energy or how hot something is. The tool that we use is going to be our thermometer. The metric unit is going to be degrees Celsius. The way we would write that would be degrees Celsius. Our customary unit, or what you might hear in America, would be Fahrenheit. Let me make sure I spell this right. Next, we have weight. Weight, the tool that we will use in science is going to be called a spring scale, but you can just write a scale. But this right here is called a spring scale. And the unit is going to be grams. Customary units would be pounds or ounces for this one. And then last but not least, we have length. For this one, we would use a meter stick or ruler. We are going to measure in centimeters or meters. Okay, the customary thing that you would hear in America would be inches or feet. Okay, and to be clear, mass is the amount of matter in an object or how many atoms it takes to create the object that we're talking about. Volume is how much space something takes up. Temperature is the amount of thermal energy or heat energy in an item or in matter. Weight is the amount of gravitational pull on each of the atoms that makes up the object, or the amount of gravitational pull on the mass. And then lastly, length is how we measure how long or big something is.